We have research scientists coming from all the way from Germany to talk about their cilia research, and they're going to talk communication at cellular level. We have Dr. Emily, Julia, and Jannis. So let's give them a warm welcome. Over to you guys.
Thank you. Hello, everyone. Can you hear me? All the way to the back? Perfect. Okay. My name's Jannis, and I'm from Helen Maisimera's lab. I heard most of you guys know her. She has a laboratory in Mainz in Germany. And with me up here are 3 other researchers. We have Viola, who's also working in Helen's lab. And then we have Emilia and Julia, who are both from a laboratory in Cologne, the Nephro Lab, which focuses on BBS and the kidney. And today, we're going to talk a little bit about the communication at a cellular level and how this is affected in BBS. So let's get started. And first of all, thank you for inviting us and letting us speak here. I'm a little bit nervous, but you have such a great and welcoming atmosphere here that makes me feel very comfortable. That's really nice. Right. So, and also, if you have questions at any point of the talk, feel free to ask questions, raise your hand. I'm sure you heard that a million times, but there are no stupid questions, really. So, really, if you don't understand something, ask questions. But we'll hopefully also have a chance to ask some more at the end. We don't have a presentation.
No, I know. I just wanted to see if I had a holding one, but I don't. That's fine. Sorry. Carry on, Jannis.
Okay. Okay, this morning we heard a lot about what we call translational research. So we talked about gene therapy or setmelanotide. And this is all translational research because it's aiming to directly develop a therapy. So what we're mostly doing is basic research. So this is one or even several steps before that to really look at cellular level or microscopic level or even more in detail to really understand what is happening in the cells when you have BBS and to understand in detail what is going on. Which is necessary to then maybe develop therapies way later to really understand what's going on. And before we start, I want to go over the basics of cellular biology. I'm sure a lot of you heard about this, but maybe there are some new people here I heard, maybe some of you don't. So I will give a quick introduction. So most of you probably know that our human body is made out of cells, which is the smallest functional unit or autonomous unit of the human body. And you can kind of imagine a cell like a house. So in a house, for a house to properly function, it needs energy, so does a cell, or it needs someone that takes out the trash, ideally, that also a cell needs to do that. And a house needs to receive signals from outside, and for that it has an antenna to know what is going on around it. And so does a cell. And this antenna is the primary cilium in the cell's case. And we recently found out that the primary cilium can not only receive signals, but also send out signals in forms of little packages. And that these packages are received by other houses. And we looked in our cell models in these packages, and we noticed that when the cilium is not properly functioning, these packages that they send out have a different content. So these packages are called vesicles, and they can contain proteins or DNA or RNA, which some of you maybe heard about, and also lipids, which are basically fatty acids that sit on the outside. But we noticed that the contents were different when they were coming from a cell where the cilium wasn't functioning properly. Like, for example, in a cell with mutation in a BBS gene. And not only did they have a different content, but they also had a different size, and there were many, many more. And we thought to make it a little bit more fun and a little bit more interactive, we're pretending now that Emilia and Julia over here are two perfectly functioning cilia, and they're sending out little Lego bricks, which are these vesicles, to you guys. Whoever wants to participate, just raise your hand, and who doesn't want to, just scare them away. Yeah, so they will send, they will distribute little Lego bricks, and Viola over here will pretend to be a non-properly functioning cilium, and she will also send you little signals in forms of Lego bricks, which we pretend are these vesicles, which will be smaller and more. So each of you who receive a signal from a functioning cilium will get one brick with 6 sort of bumps, and everything that receives from a non-functional cilium will receive 2 bricks with 3 or 4 bumps. And you can feel which one you got. And then you will also get a balloon with it, and I'll explain what's up with that in a second. Yes, a question. No, yes. Ah, okay, sorry. I already see some people inflating them. That's perfect. So, try and figure out which of the signals you received. Did you receive the vesicles from a functioning cilium? The one that has 6 bumps and is only one of them? Then you can take your balloon and inflate it, and don't tie it up, but inflate it to what I would say is a medium size. I'm also going to do this at the top now. A little bit smaller than head-sized. Just the healthy ones, though. Just the healthy ones. The ones that received the small Lego bricks are not going to do anything at the moment. Okay, and we're pretending now that these are cells that received vesicles from another cell with a functioning cilium. This cell is quite stable. It's not inflated too much. It shouldn't be inflated too much, also not too little. And you didn't tie the knot yet, which means if I would inflate this balloon more because of external stress, which I'm going to do right now, the cell potentially could compensate, open up the opening, and then deflate again. So this cell is able to react in a proper way and doesn't have any problems reacting so much to extracellular stress. Now I want the ones that received the Lego bricks from the non-proper functioning cilium to inflate so the ones that received 2 Lego bricks that had 3 or 4 bumps, to inflate their balloons and really inflate them a lot. Not so much that it's bursting, we don't want to scare anyone off, but just so you still can tie it, and I also want you to tie it up if you can. Okay, I see some very inflated balloons. That's very good.
Can you imagine?
I'm also doing this now. Okay. And these are the cells that received a signal from another cell with a non-properly functioning cilium. And you can see that this cell now is very big. It has a lot of pressure. It might more easily pop than the other one. And it has no way to regulate when there's extracellular stress coming up. So there's no way we can deflate it again to get rid of this this pressure that's too much. And what I'm looking at in my research is I want to know or understand how the content of these Lego bricks, of these vesicles that are traveling between the cells and being sent out by the cilium are different when the cilium is not functioning properly. And I want to understand where they come from so we can see what impact they have on the receiving cells. Because you can imagine if you want to build up an organ that is also made up out of cells and you use a lot of these very inflated balloons that cannot cope or cannot regulate well enough, you might have problems in these organs or tissues. For example, one of these is the kidney, and Emilia will tell you, or Julia first will tell you now more about what happens in the kidney when the cilium is not functioning properly.
Thank you, Jannis. You all can hear me? Perfect, thank you. So, Emilia and I will talk a little bit about the kidney. And as you probably all know, the kidney is a super, super, super important organ of our body, right? It is the filtration unit of our body. It filtrates our blood, it concentrates our urine, and we know from our research that probably a lot of people who are living with BBS have experienced some kind of problems with the kidney. And as we are here, maybe you can help us and just give us a quick overview. If you have experienced any kind of problems with your kidney, maybe you can just briefly raise your hand. Yeah, I see there are some people who are raising their hand, having problems with their kidney. So you know this is very important to talk about the kidney. And if we have some malfunctioning in our kidney, this is a serious problem. And as Jannis introduced us to these big balloons, you can imagine if these are cells in our kidney, these are big and they're needing much space. And some cells, the healthy cells, do not have any space left. So what are they doing then? They probably die. And we are focusing in our research about these dying cells in our kidney, and we want to prevent the kidney from dying cells and from cyst formation or even maybe kidney transplants or dialysis. So Emilia will tell us a little bit more about this kidney malfunctioning and what we want to do against it.
Hello, and thank you that I can be here. I hope you hear me well. As Julia nicely introduced, we are working with the kidney, and she already mentioned that healthy cells can be displayed by the really big fat cells, so which we also can in the end occur, of course, of cysts. But how the healthy cells or some cells disappear in the kidney? And probably this is due to cell death, or so we call it regulated cell death. And there are two different ways how a cell can die. So one, imagine I will die, and I say, okay, it's just me, I will not harm anybody else. So I just leave silent. So the kidney will be not affected at all anymore. But on the other hand, I can also say, I die, okay, I will force all of you all to die as well. So this is called inflammation, and we have inflammation in the kidney. And as you can imagine, this is super dangerous and has much more impact in the kidney. Of course, then we lose healthy tissue, the kidney gets unfunctional, what can we do? And we were wondering, okay, we have the kidney with cyst formation and defects, and on the other hand, we have the primary cilium. So the first question was, do they have something in common? And yes, they do. If the primary cilium shows a defect, any kind of, if it's shorter, longer, have a problem in signaling, this leads the cell to its inflammational cell death. So automatically, the cells decide, I will harm more surrounding tissue. If the primary cilium is well functioning, then the cells can be like, I go silent. So this already harms the tissue more if we have a defected primary cilium. But to do something against it, it's super hard to tackle the primary cilium. So we thought about another opportunity. So what we do, we tackle cell death immediately. So in the biology, we have a lot of different pathways, which different proteins, which getting into cascades and communicate with each other. And we just decided, what is if we delete one of these key players in cell death? What would happen? And interestingly, by knocking out or removing one of these players, we can ameliorate significantly the kidney function and the kidney phenotype. This is already super, super, super cool, and something what, of course, can impact also some further research in the direction of therapy. And now what we are doing is, we want to do this, can we do this on treatment basis? Of course, we are using in vivo models, like this morning mentioned already, we use mouse models. So currently, we try to develop different patient mutation mouse models that we can treat them with different inhibitors against cell death. So we block again cell death particularly, and we want to see, can we rescue again the function of the kidney, which would then prevent in the end, hopefully, the goal in the future, the patients to undergo dialysis or even kidney transplants. And of course, this is all based on kidney research, and it's hard to get all the samples. But we already went through different patient days and collected a lot of urine samples. I think on the last patient days, we collected over 4 liters of urine of different VS patients. It was fun to work with. And, but for this, we now have like from BBS 1, BBS 10, BBS 7, BBS 12, BBS 4, 6, 8, we all have like stable cell lines which we can work with. So really we have patient materials to start the research with, and this is kind of incredible. And this is actually what we are doing in Cologne. And I don't want to talk any more about the research. I want to give you now the opportunity to ask us any questions to all 4 of us, whatever you like, regarding research, and we hopefully can answer your questions. Yes, do you want to go with?
Hiya. I was diagnosed with chronic kidney disease in 2017, but apparently in 2014 it was actually, that's when it started, and I was on a lot of anti-inflammatory medication. It might not be, it's not an easy question, sorry, but can you say whether it is due to this BBS or the anti-inflammatory medication that may have exacerbated it?
So you mean in terms of which kind of inflammatory pathways are activated in BBS?
So I was taking like ibuprofen, naproxen, medication for pain management, and the chronic kidney disease was only diagnosed at a later date.
Yes.
So it's difficult, like I don't know whether it's a BBS that was a primary factor in my kidney deterioration, because I'm now heading towards dialysis, kidney transplant, which, it's not.
So even though if all these cell death players are super, super important, they cannot prevent the occurring of cyst formation in the kidney, but we can definitely delay the progression of kidney diseases. So even though in the late state of kidney diseases, we can prolong the progression, and hopefully we expand the time until we have to go on the dialysis or heading for a kidney transplant. In terms of medications, there is one medication which will soon hopefully get into a clinical trial, which is one which also directly inhibits the cell death player I'm talking about, because I don't want to get too much into research or in scientific language, but we have like at the moment 12 different ways, inflammatory ways, how a cell can die. And BBS is just heading for one of it. And many medications do not even tackle this particular cell death pathway. So this is something new, what we now have to expand and discover more, that we can go into the direction of like a suitable inflammatory treatment.
I've now been prescribed Jardiance, which apparently is for type 2 diabetes and heart disease. It's now been deemed safe for people with chronic kidney disease. I've only started it recently, but apparently it helps to slow down chronic kidney disease progression.
I hope so.
I hope so too. Hopefully I won't be needing dialysis just yet then, fingers crossed.
Yes.
So, thank you.
You're welcome. Any more questions?
Yeah. Are there any foods or drinks which you just are good for good kidney health?
Oh, hard question. I mean, I'm coming from a nephro lab, so maybe I can say something. So at least some of the medical doctors in our lab, they're trying to do this keto diets at the moment, and they predict that they have like a better or good output for the kidney. But I'm not focusing in my research on this. I can just, this is the only thing what I can add to this. Anyone else?
Any questions online?
There's a question.
I'm just wondering, does the infrared technology, like an infrared sauna blanket, does that help with BBS or any of the kidney stuff?
The first part, I didn't get it.
Does an infrared sauna blanket help with kidney or BBS?
I don't know, sorry. Do you know? No, sorry, I can't answer your question there. Okay, no more questions? Perfect.